Hey guys, Eric here at yuelbeast Designs. Today I'm going to take you through part of our prototyping and conceptualization process. While sometimes we work with hand-drawn sketches, more often than not, our designs start inside SOLIDWORKS. Here we're putting the final touches on a 3D model and adding fillets for a more fluid look. There are a couple different ways we program our machines to form metal, but the fastest is utilizing offline bedding software. Here, I am attributing different contact points to a flattened 3D part, as well as checking for potential issues that might exist within the part's geometry. Just because it exists as a model doesn't mean it can be practically made. There are a lot of small issues that can creep up in the forming process that we hope to alleviate here. Everything from the hole location to the length of flanges is scrutinized before moving on to laser cutting. After attributing the correct bend sequencing and checking the part, I move over to our laser cam software. Although there are powerful auto tool features in most pieces of cam software, I find it really important to inspect the laser sequence of each part and manually position the tabs. Laser tabs are small pieces of metal left on a cut to prevent cutouts from damaging the laser head. In the case of this concept build, I will do this for each unique part of the assembly. Moving on towards fabrication, the first step is always finding the correct material. While our concepts and prototypes often have some material flexibility, at this stage in the process, it is too late to change the material or thickness as the laser and forming programs have already been made. Because of this, I have to carefully search and measure from cut down pieces of material we use for small operations such as this. Once the ideal material is found, the sheets are loaded onto one of our lasers and fed into the machine to be cut. Our fiber laser has two interchanging tables that allow for the machine to continue running even as parts are being offloaded from one work surface. Here, we are watching the laser cut 3/16 material that we are using for a majority of this design. It only takes the laser about a second to pierce into the material, and it will cut equally fast. It's always important to pay close attention to the machine while I was cutting prototype parts such as this. Even though I have already spent time optimizing the program, it can still not be enough. Issues such as part tip-ups or miscuts can damage the head or misalign the laser beam. After the program is complete, the parts are removed from the sheet and checked for warping that can occur from the heat of the laser. Edge finishing is an important operation and something we try to do diligently. Here I am going to sand or file off all edges and tabs that are left over from the laser. Now it's time to bend each part as programmed. Each bend is checked for square as well as measured and adjusted as needed. It's very important to pay attention to what you are doing when using any kind of machinery, but this is especially true for hydraulic brakes. In this video, I'm using a bending method called air bending to stretch the material between the punch and the die. The amount of stretch is estimated, but not always exact, as there are many factors that can determine how much material can grow or shrink. Oftentimes, there is quite a bit of adjusting that needs to be done on a prototype or concept build, as there is very little optimization on the part. This lack of optimization can be seen when I have to add a pressure inserted nut to a laser cut hole that should have been a 632 tap. Thankfully, I was able to drill out the hole and insert the nut instead of recutting the part. Now it's time to assemble the parts for a quick fit test. First, we place and screw the motherboard plate in between both sides of the outer wrapper we formed earlier. This is one of those areas that we need to be tight but not too tight. After the motherboard plate is positioned, we move on to the radiator flange. First, we screw the radiator onto the flange and then attach the entire subassembly to the case. Moving on from the radiator flange, we are left with the formed backplate. Unfortunately, I had to do a bit of adjusting to the backplate, as it was slightly overbent and overall too small for its frame, but I was able to get it on. And there we are, a complete concept built. Please feel free to check out our other videos. We would appreciate it if you subscribed. You can find more documentation of our work on our Instagram or at yuelbeast.com.